So everybody take a look at it. We'll see how you did. We kind of left off at 31, correct?
Yeah.
Right, so we're on 32, right? Yeah? Is that right? So 32. Okay, let's just go ahead and get started. And what I want to do is, like I said, the reason why I like Notability so much is because I can just take this and just shrink it down out of the way. So if I need, I can come back to it. And now I can just start over right here so I can see 32. Again, I really would prefer everybody to write it out. 0.2c plus 4 equals 6. Right? And then from here, 0.2c equals 2. And so c was equal to what? C is equal to 10. Now remember, your job is to speak up when you're not sure about something. All right, so this was question number 32. All right? Feeling good about that, right? All right, let's take a look now at 33. So let's see how you did on 33. So f over 3 minus 9.2 equals 3.5. So f over 3 equals what? Help me out, guys. Yeah, everybody should be able to say it because you did it on your home. You did it for homework. And so now f is equal to. Is everybody happy with that? 38.1, right? That's good mental math practice, right? 12 times 3 is 36. 3 times 0.7 is 2.1. 36 and 2.1 is 38.1. Everybody okay with that? All right. Let's check out 34 now. Now notice I'm going to write it like this. Negative 3u plus 7 divided by negative 8 equals 4. I just think that's the better way to write. We don't write double negatives anymore. Do I agree? And so now this is the exception where the first thing we need to do is to multiply by, multiply by negative 8. So now we just say negative 3u is, or negative 3u, bless you, plus 7 is equal to negative 32, right? And so now we can say negative 3u is equal to negative 39, right? And so u is equal to what? U is equal to 13. Anybody have any issues with that? Yes.
Oh wait.
Yep, good job.
How does negative 3u go to like plus 7 equals 32?
Because very good question. All right, I'm going to move this over so I can show you better. Okay. All I did was I came over here and I multiplied both sides by negative 8.
Okay.
And now what happens? Hold on one second. These cancel. You agree with that?
Yeah.
All right. Yes, sir.
You're adding positive 7, and why did it go to negative 39?
Because to undo plus 7, we do what? Right? Remember, we're always going backwards. All right? If you think division, we multiply. Addition, we subtract. All right? We're just going backwards. All right? Good questions, guys. That's what you want. If you want to do better, you got to ask questions when you don't see it.
So, you once you do the negative 8, then you do whatever else is left.
That's exactly right. Because your ultimate goal is to isolate the variable. Your ultimate goal is to isolate the variable.
I don't really know how to do it that way. I just knew the top had to equal 32.
Well, now you know how to do it this way, right? But that's the most important thing. Sometimes, because I always tell kids, I can make the numbers harder. Do you agree with that? You know, so you couldn't like look at it and see what the answer was. You with me? All right, there's 34. Let's take a look at 35. All right. Now, this one, I really want to concentrate on. All right. Because I want somebody to tell me what 3 consecutive odd integers are. Just tell me 3 consecutive odd integers. Tell me.
19, 21.
That's exactly correct. 19, 21, and 23. The question is, how do I solve that? All right, now there's some shortcuts here, and I'm not really interested in the shortcuts right now because I'm trying to explain to you the reasoning behind it. All right, I feel like that was really easy to solve. Just divide by 3 and you get 21. That's the one in the middle. The one to the left, the one to the right is the others. That's how easy these problems are. But is that really how we want to do it? No, because we can make it harder. All right, that's what I'm trying to tell you. We give you the easy problems just starting out. All right, so I want everybody to pay attention now. 3 consecutive odd integers with a sum of 63. So what's the first integer going to be? What's the first integer?
19.
Nope. 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 Nope.
1.
Nope. We don't know. What is the first integer? We don't know. We know what the answer was because I was just mentally able to do it. So if you don't know something, the first integer would be what?
X.
There you go, guys. Look how simple that is. X. So now how do we get the second integer? If the first integer was x, the second integer would be x plus 2. Brilliant. X plus 2. And then the third integer would be probably x plus 4. Or you could have said x plus 2 plus 2. And that would be x plus 4. All right? So those are all of the possible 3 consecutive odd integers. Right? Now, a lot of people make a mistake and they say plus 1 or plus 3. But to go from odd to the next odd, you add 2. All right? Now, what do they want you to do with those? What do they want you to do with those 3 integers? Add them up. Thank you. And look what happens when I add them up. What do I get when I add them up? Thank you. 3x plus 6. And that is equal to what? 3x plus 6 is equal to 63. Is everybody okay with this? All right. So now what do I do to both sides?
Oh, subtract 6.
Subtract 6. So 3x is equal to 57. So 57 divided by 3 is obviously 19. Everybody happy with that? So the first number was what? Bless you. The second number was, and the third number was. So now you know how to do the math to solve the problem. You just didn't figure it out in your head. All right? Yes, ma'am.
How did you get 63 on the 3x?
It says in the problem it equals 63. Don't worry. Don't worry. It's okay. How's that, guys? Does that make sense now? All right. So again, are you allowed to just tell me the answer on the test? Yes, but you're probably not going to get the whole credit, right? Because I just want to see the math. Plus, we can make the numbers a little bit harder. All right. And I just want to see the process. All right, for now. All right, let's take a look at the next one, 36. All right. So now that we did 35, you should be better at 36. So I'm going to come down here. Find 3 consecutive integers. So how do I write 3 consecutive integers this time? Tell me.
First one is x.
The next one is?
X plus 2.
Are they consecutive evens? So give me an example. Give me an example of 3 consecutive integers. 13 what?
13 or 11, 13.
Yes, that would be consecutive what though? Consecutive positive odds. We just want,
You just want like something like 13, 14, 15.
yes, we just want something 13, 14, 15. So can you tell me what they would be? X. Yay, x, x plus 1, and x plus 2. That's perfect. Do you see the difference now? Yeah, it's not really a big deal at all. All right, you just have to understand, if they're asking you about evens or odds, it's x, x plus 2, x plus 4. If they ask you about consecutive, it would just be x, x plus 1, x plus 2. Is everybody happy with that? All right. And so now, what are we doing with those? Adding them together, right? So if I add those together this time, it's what?
3x plus 3.
3x plus 3 is equal to negative 39. So 3x is equal to negative, no, negative 42. X is equal to negative 14. So the numbers are negative 14. Be careful. What's next? Negative what?
13.
And then what? There you go. See how sometimes they get confusing if they're negatives, right? Come on. We're doing a video here. All right. Does that make sense? Everybody happy with that? That's not bad. That wasn't bad at all. Agreed? All right. Remember, you got to speak up if you're not sure. Okay. So now what we're going to do is 37 through 44. Yes.
36. How did we get negative 14, negative 13, negative 12 instead of negative 14, negative 15, negative 16?
If I add 1 to negative 14, what do I get? You see what I'm saying? All right, that's why I said the negative, sometimes kids accidentally do that. They just go negative 14, negative 15, negative 16 because they forget they're adding 1. All right? So, good question. Everybody good with that, right? Simple, simple. All right, so now let's go ahead and let's grab 37. All right, now here's where I think variables on one side, numbers on the other. Does everybody agree with that? All right, so here's what I would like for you to do. Minus 5m, minus 5m, minus 7, minus 7. Did everybody see that? And so now we're left with what? 3m. So m equals 3. Everybody pretty good with that? Speak up if you don't know. Come on.
So how do we get negative 5m?
Because remember, I'm putting the variables on one side and the numbers on the other. And when you move something, you do what? Change the sign. Because we want them to cancel out. Do you agree with that? Yes, ma'am.
But
Good.
you would only do the inner one, so you would do minus 8m.
Well, here's what I want to show you. Very good question. If you have an equal sign, I always want either the variables over here and the numbers over here, or the numbers over here and the variables over there. That's your choice. Right? So you're moving things. Are you a variable? You go on one side. Are you a number? You go on the other side. You with me? All right. Yes, sir.
And if you're differently, what if, like, let's say we put the variables on the other side, wouldn't it be minus 8 then?
Yes?
And wouldn't that be two different numbers?
Ooh. You might have something here. All right. So let's see if he's correct. All right. Again, very, very good question. So let me see if he's right. So minus 8m, minus 8m, minus 16, minus 16. Negative 9 equals negative 3m. M equals 3. Same answer, right? Do you agree with me? It's just not only did the variable change sign, but the number changed sign. All right? Very good question. All right, let's check out 38 now, guys. Now again, I'm trying to isolate, right? So to me, the easiest thing to do would to just go ahead and move the 2h over here. The bigger that. All right, so when I do that, that's just a what? Minus 2h, right? So now I have negative 14 equals negative 7h. Right? And so h equals 2. Come on, that was pretty easy, right? All right, I feel like we should be pretty good at this. All right, let's look at 39 now. Let's see what happens. Now, to me, I'm going to go ahead and put plus 3j minus 21 minus 21. Again, I like to show kids these cancel, right? These cancel, right? And so now I have 6j equals what? Negative 12. Everybody happy with that? And so j equals what? J equals negative 2. Yes, sir.
It doesn't matter if you did minus 3j and minus 3j.
Mm-mm. It'd be the same answer. Yes.
I didn't really understand this problem. Like, if you did plus 3j and plus 3j, wouldn't it cancel out both of them?
3 plus 3 is what?
6.
Not 0.
I see.
Right?
Yes.
All right. Yes, ma'am.
When I did it, I just knew that plus 3j and minus 3j would cancel out, so I didn't even do those. Would that be acceptable?
Yeah, it doesn't matter. Some of you, here's how I really want you to do it. Look up, guys. I want to show you something. Here's what I'm expecting. Because if you understand the logic, then the mental math is the easy part. Does everybody agree? So now, please pay attention so you can understand what I'm saying. Here's what I was expecting you in a couple weeks. I'm just going to put this problem on the board, and you're all just going to look at that and say, well, obviously j is negative 2. All right, eventually you'll be able to just look at that and say j equals negative 2. But right now I'm doing what? Training you to think backwards. Everybody understand what I'm saying, right? And eventually you'll get it in your head where we're just going backwards, right? That's why I say when I move something, when you move something, you do what to the sign? Change it. Bless you. All right? So over here, this is what I'm doing. Visually, in my mind, I'm taking the negative 3j and putting it over here. When I put it on the other side, the negative 3j becomes what? Positive 3j, right? So what's 3j plus 3j? And then I'm going to move the 21 over here, so that becomes a what type of 21? Negative 21. So what's 9 minus 21? Yeah, negative 12. Be careful. So now it's just 6y or 6j equals negative 12, then j equals negative 2. This step right here should be optional. Bless you. Should be optional if you understand what we're doing when I'm saying you're moving variables to collect them. That's what you're doing. All right? You good? All right. So I feel pretty good about that. You have to be excellent at that. If you're excellent at solving equations, the class is going to be simple. If you're not an expert at solving equations, the class is hard. All right? So that's why I'm saying don't sit here and not know something now. Speak up.
How do you know to like add 3 to the negative 3j and not subtract 3 from the positive 3j?
You can.
And it'll still work?
It'll still be the same. We've done this the third time now.
Okay.
I can show you. Let me show you just to make sure. All right? I'd like everybody to listen again. All right? Look up so I can show you. So I added 3j, correct? This time, instead of adding 3j, I'm going to move the 3j over here and the 9 over here. So if I do that, that becomes minus 3j, minus 3j, minus 9, minus 9. 12 equals negative 6j. J equals negative 2. You agree with that or not? Now I think I can see over here, j is negative 2. Down here, j was what? So it's the same answer. Plus, you can just look right on your own paper and see it. Everybody see what I'm saying? It doesn't matter as long as you put all the variables on one side and all the numbers on the other side, it's going to always work out if you change the signs properly. Remember what I said, guys. Most important day today is make sure you're excellent at solving equations. All right? So here we go. After 39, let's go ahead and grab 40. All right? Because 40, again, could be a little trouble for some. Hopefully you didn't think it was that hard. All right? So for 40, For 40, what is that actually called? A what? Very good. A proportion. How do you solve proportions? What did we do last year?
Make them equivalent.
Well, they are equivalent already, but there was a rule we did. We said we cross multiply. Anytime you have a proportion, you can cross multiply. Very nice. Very good. So what do I mean by cross multiply? That means you're going to multiply these two things together and what? These two things together. Does everybody agree with that? Does anybody know why cross multiplying works? I used to go, why is that? How did they think of that? Does anybody know why that works? All right, let me show you why it works, because I think that's important. This will help you understand. So, does 1/2 equal 1/2?
Yes.
So what happens if you multiply a numerator and a denominator together? What is that? 2. And what's this? So they are what? They are equal. True? So now I'm going to show you something a little bit different. Please watch, because this is important. 1/2 is also equal to what other fraction? Somebody tell me. 2/4. So then somebody came along and said, wow, look how cool this is. To tell if they are equal, I can just multiply what? The numerator and denominator on the diagonal or across. So what's 2 times 2? And now 1 times 4. Now you know why that's true. Everybody see that? If fractions are equal, if you multiply the numerator and you multiply the denominator of opposite fractions, they're always going to be what? They're always going to be the same. They're always going to be equal. Everybody good with this now?
So like a proportion is just two fractions
That are equal. That's exactly what that means. All right? So now when I cross multiply this, it's going to be 2 times x minus 3 equals 4x. Is everybody happy with that?
Yes.
All right, now I'm going to, because you guys are advanced, I'm just going to go ahead and show you something. Do I have to distribute here? I could what? I could just divide by 2. That makes it easier. Watch. If I divide by 2, right? So now I have x minus 3 equals what? 2x. Everybody see that? And now I'm just going to move the x to the other side. When I move the x to the other side, I get negative 3 is, well, minus x minus x. Come on, take a look at that. Yes, sir.
Don't you could divide like a variable by a number?
I never said that. Right, so if I say to you 4x divided by 2, what is that? If I say 9x divided by 3, makes sense, right? Yes, sir.
How did you get the 2x?
Because you divided.
Yeah, he's right. Exactly right. So look now. You see it now? Now look, here's what I was trying to say yesterday. I may not have done a very good job saying that. So here's what I want you to try to think about. Look right here. And this is what I'm telling you about being smarter. All right, listen to me for a second. Put your hands down. Just listen for a second. All right, he asked me a good question. How did you get 2x? So here's what I kind of would want you to try to start to do. What happened to the 2's?
They canceled out.
They canceled out, right? So over here, I have a 4x and a 2. What did I do with this fraction bar? What does that mean again? Yeah, that's all. True. So it's just 4 what? Divided by 2. That's all. All right? Yes, sir.
So you minus x from each side.
Yes, sir.
Wouldn't that just make it negative 3 equals 2?
Yeah.
No. Look, this is negative what x? Negative 1x. That's what you forgot. All right. There is technically, think about it. There's technically a number. There's technically a number 1 here.
Oh.
Right? Remember that? 2x. If there's no number in front of the exponent, it's a 1. Right? Yes, sir.
Why do you write negative 3 twice? You just do that.
Here to here?
Yeah.
Well, because traditionally we put the variable first.
Oh, okay.
You with me?
Yeah.
All right. Quickly.
Why'd you move the 2 up to the top left?
This, how did that become a 2? Is that what you're asking me?
Oh, in my best.
Yes, ma'am.
Why did you, like, how did you know to divide 2?
Because it would just make it easier. That's what I'm always trying to do. See, this 4 can be divided by 2, so instead of distributing, if you distribute, then you get the same answer, right?
Because you can't
You see what I'm, You see what I'm saying, right? So I'm just saying in the future, if you recognize that, wow, it would make the problem easier if I just went ahead and divided it first, then it's the same answer, right? That's what I'm trying to show you. All right? So here we go.
Okay, so what happened here is that you moved the 4 that was originally being divided, and then you put it at the x.
Are you asking me what is 4x divided by 2?
Like, how did the 4 get there on the x?
Because it was on the problem, wasn't it?
I don't think I meant the right
Okay.
It's number 40.
All right. All right, so here we go. Let's take a look at, after 40, let's take a look, let's grab 41. So again, cross multiplying here, it would be 4 parentheses 6r minus 7 equals 10r. Now, in this case, should I divide both sides by 4?
No, it's not rooted.
No, because 10 doesn't divide by 4 evenly. Everybody see that now, right? So I would just think it's easier to just go ahead and distribute. When we distribute, that would be what? 24r minus 28 equals 10r. Is everybody happy with this? Yes, sir.
Keep the 4 to the beginning.
Cross multiplied. We went this, and then we went times this. You good on this? All right, now I'm going to go ahead and throw the 24 on the other side. If I move the 24 over, it becomes negative 24, right? So now listen, guys. Come on, you guys are brilliant. If I make it negative 24, that means there's going to be what? Negative what? Negative 14r. Did I hurt anybody's feelings? Look, this then would be negative 14r equals negative 28. Now remember, I'm telling you, now I'm working on the mental game, right? If you go, man, what are you talking about? How did you get negative 14? Yes, ma'am.
So you would only distribute the 4 on the left side?
Yes, yes. Because that's the number in front of the parentheses, right?
Oh, yeah.
You would be, right? Okay.
So you did 10r minus 24r?
Yes, 10r minus 24r. You agree with me? Right? Come on, guys. You have to see that, right? Now, listen. Bless you. Do I care if on your test, or do I care if you do minus 24r minus 24r? I don't care. Well, you're smart enough. You should be able to say, I'm working backwards, so, right? All right. So final answer here. R equals what? 2. Brilliant. R equals 2. All right, so here I'm going to grab 42. And hopefully you were listening to me on 42. So what can I do on 42 here, guys? Now look, everybody look up. Everybody up here should be able to say, obviously, P is equal to 7. You should be able to look at that and say, that's 7. If you're not, you're a little behind. So I want to catch you up. All right? The reason why I'm saying that is because what is 33 divided by 3?
11.
11 minus 4.
7.
Is everybody understanding me? Come on now. Look, you can't be afraid to say, hey, man, I'm not sure what you're doing. Because we're getting harder, right? So if you can't see it now, you're not going to see it in a few minutes.
I don't really get
So here, we're multiplying by 3, right? So how do I undo multiply by 3?
9.
So what's 33 divided by 3?
11.
And then I'm left with plus 4. So 11 minus 4.
7.
There you go. Now, how do I know I'm right? Because what's 7 plus 4?
11.
Times 3.
33.
What it's supposed to be. We're just going backwards. All right. This is what I'm expecting. If I write a problem on the board like that, you can look at that and just say, wow, that's super simple. You will be, when you get to high school, people think you're crazy. Because they never were understanding you're just going what? Just thinking backwards. All right? So is everybody good with that? All right, so let's try, let's look at 43. I'm going to go ahead and grab 43 now. All right, let's go ahead and distribute the negative 2. When I distribute the negative 2, we end up with negative 2b plus 6 minus 4 equals 18. Everybody happy with that? Now what's 6 minus 4? So now we have negative 2b plus 2 equals 18. Now what do I do to both sides? So negative 2b equals what? 16. So b equals? Yeah, don't forget the negative. B equals negative 8. Yes, sir.
Actually, it says negative 2b plus 2 equals 18. All you do is minus.
I don't see where. Oh, okay, go ahead.
Oh, that's what you did.
Yep. Good? Good job. All right, let's grab 45. Or 44, thank you. Here we go. Let's take a look at 44. What do I need to do? Distribute a what? Distribute the 4 and distribute the 8. So when I do that, 12w minus 8 equals 16w plus 24. Are we okay with that? Now I'm going to move the 12 to the right and the 24 to the left. So I'm going to put a minus 12w. Now the reason why I'm doing the minus 12w, remember I'm always trying to keep the variable positive. So now I have negative 32 is equal to 4w, right? So w equals what? W equals negative 8. Yes. So now remember, here's how you're going to help me better. Is this good for you or not?
Yes.
Okay. So now what I did was I moved this over here, and then I moved this over here. You see that? So I put a minus 12w, and so 16w minus 12w is the 4w. You agree with this?
Yeah.
You okay now?
Yeah.
All right.
What if to make it simpler, you divided 8 by 4?
Yeah, you can actually do that. I was going to say that.
And then
That's
just
good.
do
And now you just,
minus
yeah, you would get 3w minus 2, but then you'd have to
4W.
distribute. But then you, yes, that's right. You get the same answer. That's what I'm trying to get you to show. I'm trying to show you. Lots of things you can do with numbers if you're consistent. Very, very good. All right, very good. All right. Now, before we go on, guys, you guys know I think you guys are great. And sometimes I think that the iPad is good, and sometimes I think it's not so good. All right? Because you can kind of see how on my paper I kind of have things thrown around. Right? I don't mind you do that, but it has to be so where I can understand it. So I'm going to look at your iPads every once in a while, right? And part of being good at math is being organized. Do we agree with that? All right. That's why we're going to work on pencil and paper half the time. All right. So I'm not a big fan of, I mean, I really enjoy doing the iPad stuff, but for students, the pencil paper is kind of a good thing also. All right. Yes. Right. I agree with you. All right. So now, section 2-6. All right, we don't have much time. I said we weren't going to have any homework. So what do you think these are? Didn't we already just discuss this? These are all just the what? Yeah, the cross multiplying, the proportions. Does everybody agree with this? So I'm expecting everybody here to be able to look at 55 and say, are those equivalent? Bless you. Are those equivalent?
Yes.
Yes. Now, first thing you could do is you could just reduce that if you wanted to. Because to me, dividing by 9 was easier than multiplying 27 times 5 and 3 times 45. Right? So you can always reduce fractions. So that was definitely a yes. And 56 was definitely a what?
No.
No. All right. So yes and no. Solve each proportion. Now, this was no joke. You did this in 5th grade. No joke. You did it in 5th grade. All right. So I really didn't even want to put this on here, but I thought just to be sure, everybody should be able to look at that and say, obviously, A equals 20. Obviously, T equals 56. Now, here's where some kids have a little bit of trouble, but we don't, because what could I do to the 9 and the 16? Reduce it, right? So we could just cross that out and make it what? 3/4. Now it's easy to see that G is what? G is 12. I just think you should know that. Right? Yes, sir.
You could have also done it like across.
Yeah, you could have. Yeah, you could definitely. Yeah. All right. As long as you know, I'm in good shape. Yes. We're gonna do it on Thursday. I'm gonna call it a quiz. Oh, sure. I'll try 16. All right. It says that the length of the gem as shown on the builder's blueprint is 12 inches. All right. So here we go. So first of all, 3/4 inches is to what? 5 feet. And they're telling me they have something that's what? 12 inches. So I want to know how many feet that is. So I think this is a very good problem because it just reviews what? Fractions, right? All right, so let's take a look at this. When I cross multiply, I get 3/4 x is equal to, and 12 times 5 is? 60. Thank you. And then how do we solve a fraction? Multiply by the reciprocal. So now we're putting a 4/3 here. 4/3 cancels. X is equal to
80.
Do the division first. Yes, 80. So we say 80 feet. 60 divided by 3 is what? 20. And then 20 times 4 is 80. Yes, sir.
I did that. Like, I got the right answer, but I didn't do it.
And that's perfectly fine. There's so many ways to look at it. Yes, sir.
I look at it, and then I saw like that 3/4 of an inch, like you have to times that by 16.
That's very smart. Very smart. Very smart. There's so many ways to do it. Yes, sir. Again, here we go. Yes.
How do you guys feet not inches?
Because we were converting 12 inches to how many feet? So on the numerator, we put the inches. In the denominator, we put the what? Yes, sir. Does that make sense? You do it. All right, you guys, I'm super proud of you guys today. Already got through everything, so you have what? No homework. Take a break over the weekend. All right, listen, if you know who you are and you struggle with a particular section, just go ahead and do what? Practice that section. All right, practice a section if you didn't know. All right, if you feel like, wow, this was really good explanation, you think you got everything covered, then you're all set. You don't have to work. All right. Again, great job today, guys. Great job.